As we continue through this section, we'll be working with arithmetic and geometric sequences. And what we have going on first is the definition of a recursive arithmetic sequence. And what you should notice here is this plus d number, which we refer to as the common difference. Because what an arithmetic sequence is either add or subtract. And because subtraction is the same thing as adding the negative, that's where we could just say that. The same number, the common difference, is the same number from one term to the next. And each one of these is a little bit different, but they're pretty much the same problem. Because as you look at it, as you recall from the previous section, that this means the first term is 2. And I'm going to just jump to the answer, and you might need to rewatch this because this is confusing for students, is you take, in order to find the second term, you take the previous term, if I can spell previous correctly, previous, and you add 6. That's what that means. So your first term is 2, the next term would be 8, because you add 6 to it, and then 14, and then 20. And that is it. So the next one's a good problem because instead of being a recursive definition, they tell you what the first term is, and then the common difference is adding -4. So that's why the second term would be 4, the third term would be 0, just subtract 4. And notice I'm stopping once I give the next 3 terms. If you ever are confused by where to stop, just give me more terms. It's better to be safe than sorry. And then the next one, it looks different than letter A, because instead of telling you the previous term plus 1/2, it's saying, hey, to find the next term, that's what n plus 1 is, you take the current term and add 1/2 to it. So this pattern goes 3 halves. I'm fine if you just leave it as 4 halves, then 5 halves, then 6 halves. But I will point out for you, so that's your correct answer, that 4 halves is the same thing as 2. You can't simplify 5 halves, but if you want to change it to 2.5, that's fine. And 6 halves is the same as 3. So for the next one, this may look weird, but we've done complex numbers before, and it is your recursive definition of an arithmetic sequence, because you have the plus in here. So if the first term is -3 plus 5i, the next term is adding 6 to that number, so -3 plus 6 would be 3, and you subtract 1i from it. Oops. 3, so it's 4i. And then the next term is adding 6 to that 3, so 9, and subtracting I from that, so that would be 3i. So let's add 6 again. We're at 15, and subtract I from it would be 2i. And I'm going to stop right there because that's the first, second, third, fourth term. And why did I stop there? Is because that's what they wanted. They wanted the fourth term. So what we're going to do is come up with a pattern here. And I hope this pattern makes sense. And at the end of the day, we're going to have a formula right here that you might just need to commit to your memory. So again, this is a recursive definition, and I know it's arithmetic, not only because it says it's arithmetic, but this plus 3 is a clue. So this pattern is set up where the first term is 5, the next term is 8, the third term is 11, and then the fourth term is 14. Make sure you understand that pattern. So let me just circle that. So the question then goes, well, how many times do you have to add 3 in order to get to the fourth term? Well, if you look closely, well, to get the second term, you only had to add 3 once. If you have to find the third term, you have to add 3 twice. To find the fourth term, you have to add 3 times. And you might be sitting there and saying, well, what are you getting at? Is the fifth term would add 3 4 times. The sixth term would add 3 5 times. It is 1 less than n. And you might be sitting there and saying, well, what's the big deal about that? Like, I knew the pattern, I was able to find the fourth term just fine. Well, what if I asked you for the 50th term? Would you really want to do plus 3 that many times. And then the quick answer would be, well, just take your 5, the starting number, and add 49. And where did 49 come from? It's 1 less than n. So 49 is 1 less than 50. And then multiply by 3. And you are welcome to use a calculator. I think you could do this in your head. You could just do 50 times 3 and remove a 3 and add 5 to it. Or use a calculator. So I hope you notice the pattern. If not, this is what you need to commit to memory. That a sub n, to find the nth term, you take the first term and you add to it. You subtract 1 from your number term, and then you multiply by the common difference. So make sure you circle that, put a box around it. It is super important. That's what we're going to use moving forward. Moving on, there's multiple ways of doing these problems, but ultimately the method that always works is to use this formula. And the thing is n can be any number you want. How do I know to use this formula? It tells me it's arithmetic. There's lots of things we can notice about this that we might talk about in class, but what it shakes out to is if I'm given the fourth term and I'm given the first term, what I can do is take this n in the problem and replace it with 4. And so a subscript 4, the fourth term, is 18. The first term was 6. And 4 minus 1 is 3. So at this point I could figure out by solving for d, by subtracting 6 over, I don't know if you need to see that work. I hope you don't, but if you do, 18 minus 6 is 12. And then divide both sides by 3 to see that the common difference is 4. So if you rewrite this pattern, I'll just write it up here. We know the first term is 6. We know the fourth term is 18. And when they ask you for the second term, you could just notice that, hey, my pattern for my common difference is plus 4 each time. So that's 10. This is 14. How do I know I'm right? Well, 14 plus 4 is 18. So that's one way that you could answer a few of these questions. There's other ways you could approach it as well. But I don't know how many of you would want to continue adding 4 over and over again to get to the 20th term. And that's where I'm going to go back to this formula where I can figure out a subscript 20 is equal to the first term and replace n with 20. And now that I know the common difference is 4, I can answer this. The first term is still 6 plus 19 times 4. And again, use a calculator. And earlier I did go ahead and check it out, like if you want to continue to add 4 several more times. But I've had students do that before and they lose count. So they give me an answer of like 78 or 86, which is sort of embarrassing. But you could do that, but you might be opening the door for more mistakes. I'm going to go ahead and teach geometric sequences at the same time, because the difference with geometric versus arithmetic is that we are multiplying. And I'm only going to say multiply because I don't want to say divide. But you might see a division problem, but I think it's actually this one right here, where it says multiply by 1/3. Is you might look at that and say, oh, I think we're dividing by 3 there. Well, we want the ratio, which we call r, to be a number that's multiplied. So we don't want to say dividing by 3 because that's different than multiplying by 3. That's why we have this multiply by 1/3. So geometric multiplication. So how do we do these problems? Well, again, we know the first term. It's 4. And then the ratio is times 2. So what's the second term going to be? 8. The next one times 2, 16. The next one times 2, 32. I can stop right there because that's the next 3 terms. Again, if you're scared, give me more. Next one's very similar. It's your recursive definition. It's 9 multiplied by 1/3 is 3. Take 3, multiply by 1/3 is 1. Notice I am dividing by 3 there. But we want to call the common ratio times some number. And then this last one seems to stump students. So your first term is 3√2. I'm leaving some space because the second term is 6. And I'll just show you with a calculator, because you are allowed to use a calculator, that 3√2, that when you multiply by √2, does in fact give you 6. And the reason why that works is you can multiply the radicals together. √2 times √2 is √4. And think about how I know the square root of 4 is 2. And that's how you get that number. So then the next number would be 6√2. And just think about it. And here you go. The next one will be 12. And again, if you're stumped on that, just go ahead and write it out. Like if you did 6√2 times √2, that's the same thing as 6 times √4, which is the same thing as 6 times 2. And that's how you get the fourth term. And at the end of this lesson, what I'm going to point out is your formulas are essentially the same. So let me jump down to the formula here, just in case I run out of time, because that's the meat of this lesson. Well, think back to the arithmetic sequence, where we wrote a sub n is equal to a sub 1. So it starts out the same. Now in arithmetic sequence, we put a plus right here, because it was addition. Well, this time we're putting multiplication, because geometric is multiply. Just like in the arithmetic, we put the common difference, but this time we put the ratio. And the difference between the two of them is you multiply, for the arithmetic, you multiplied the common difference by n minus 1. Well, why do you multiply? It's because it's repeated addition. Well, repeated multiplication is an exponent. So that's why this formula looks different, but it is basically the same. I'll go ahead and write it down here in green. I'll scroll down a little bit more. That in arithmetic, notice the similarities. A sub 1, and multiplication is commutative, so I could move that d in front. So the only thing that's different is the addition for the multiplication, and then multiplication becomes an exponent. And other than that, it's pretty much the same thing. So I could use this to answer these questions. So if you wanted to, you could say, okay, the first term is 2, and the pattern is times 3. So the second term would be 6. The next one is 18. The fourth term is 54. So what I could have done is that formula, that a subscript 4 is equal to the first term. The ratio is 3. I don't know if that makes sense, but the common ratio is right there. To the 4 minus 1 power. 2, 3, to the 4 minus 1 power. There it is. And you might be sitting there and saying, well, if you could have done that by hand, why come up with a formula? Well, do you want to do this 10 times? If I go back to that formula, I can just change that 4 to a 10. So again, a subscript 10 is equal to 2 times 3 to the 10 minus 1 power. And I already forgot, 39,366. And the moral of the story is very similar to the previous one. How many times did you multiply 2 by 3 to get to the a sub 4? It was 3 times. But again, the moral of the story is that it's n minus 1. 1 less than n. And you should be ready for the homework now.